Civil Engineering Academy.
Hey, what's going on, everybody? We got a short problem here, a structures problem. Find the moment at point D, which is a halfway point in the beam shown below. So we've got a beam with points A, B, C, D, E, F. And we've got some external loading here, and we're on 2 pins, and we've got the dimensions of this beam. All right, so the first thing I'm going to do is take the sum of the moments about point B, set that equal to 0, and I'm going to go counterclockwise as positive. So what do we have here? We have 10 kilonewtons times 3 meters minus 10 kilonewtons times 2 meters, plus we have these forces acting at these pins. I'm going to go ahead and call this F1, and we'll call this F2. So we have to add, we've got an F2, which is a distance of 8 meters away, times 8 meters. And we got to subtract this last load of 40 kilonewtons times, how far away is that? That's 11 meters. Okay, work that out, and you get an F2 of, I get 53.75 kilonewtons. Next thing I'm going to do is take the sum of the forces in the y direction, set that equal to 0, because what I want to find now is what F1 is. So we've got a minus 10 kilonewtons. I'm not going to write in the units just for the sake of speeding this up. So we've got minus 10 plus F1, another minus 10, plus the load we just found, 53.75 kilonewtons, minus 40 equals 0. Solve for F1, and I get 6.25 kilonewtons. Okay, so how are we going to solve for the moment at point D? Okay, the way we're going to do this is by making a cut through D. Okay, we're going to make a cut through there. I'll redraw the beam here. So we made a cut here, and because we did that, we introduced new forces in the beam. I'll go ahead and draw them. We got a moment, a vertical and horizontal load, and we're going to call this point D. We have to remember that we still have point C, roughly draw these in here, B and A, and remember we still have these external loads acting at those locations. I'll just draw them in here, but you get the idea. This is basically this segment here. Alright, so how are we going to solve this? We're going to take the sum of the moments about point D, again go counterclockwise as positive, set that equal to 0. What do you get? You have a moment at D. Okay, we drew that in, so you have to account for that. Your moment at D, plus you've got 10 times 7 meters, plus 10 kilonewtons times 2 meters away, minus the 6.25, which is F1, kilonewtons times how far away is that? That's going to be 4 meters away, and set that equal to 0. Solve for your moment at D, and you get an answer here of a negative 65 kilonewton meters. That is your answer, and it looks like the answer here is B on this one. So this is a great example of a good structures problem or a statics problem. Hope that helped you out, and we'll see you next time. Bye.